Okay, everyone. So we're going to start in section 7.4, addition and subtraction of rational expressions. And I know some of you have actually done this already, but I just want to make it clear because I know they're not easy. So for those of you who are comfortable with this, you can skip it. But I think a lot of you are still struggling with adding and subtracting rational expressions. So we're going to do some examples. First, you'll notice that if you're adding or subtracting fractions where the denominators are the same, you just add or subtract the numerators, right? So this is an example of where the denominator for both fractions is x plus 6. So I'm just going to copy this down right now. This is x times x plus 5, right, over x plus 6. And then minus, so here we're subtracting, not adding, 3 times x plus 8 divided by x plus 6. Okay? So we want to subtract and then simplify, right? So in this case, we can just subtract the numerators. So now we get one big fraction. The denominator is x minus 6. And the numerator is x times x plus 5 minus 3 times x plus 8. Right? But now we also have to simplify, right? So the simplifying part, nothing to simplify in the denominator, but for the numerator, I think we need to multiply out the x here. X times x gives us x squared, right? And then x times 5 is 5 times x. And then we have, be careful, this is negative 3 times x, so that's negative 3x. And then negative 3 times 8 is negative 24, all over x minus 6. Okay, so what can we do with the numerator? Well, 5x minus 3x is 2x. Right? And now, remember what simplify means. Simplify means factor and cancel. So we have to factor the numerator. The numerator we can factor as, I'm going to move down a little bit here. We can factor the numerator by now, right? GCF is 1, so everyone's comfortable with that. And this is a trinomial, so we're looking for two numbers, right, whose product is negative 24 and whose sum is 2. So think about that, right? Negative 24, we can do 1 and 24, 2 and 12, 3 and 8, but I think it's going to be 4 and 6, right? So negative 4 times 6 is negative 24, and then 2 is just negative 4 plus 6. So we're looking at x minus 4 times x plus 6. Is that right? Yep. And then the denominator is x minus, oh, sorry. The denominator is x plus 6. Huh. All right, so I made a mistake here. This was correct, right? X plus 6, and somehow I changed it to a minus. All right, well, that's an easy fix. That's a plus 6. That's a plus 6. That's a plus 6. All right, so yeah, the denominator was always x plus 6. I don't know why I changed it to x minus 6. That was bad. But it is x plus 6. And notice that we have x plus 6 also in the numerator, right? So the numerator, we have an x plus 6, we have an x plus 6 in the denominator. That's what we mean by cancel, right? Any factor that's the same in the numerator and denominator can be canceled, right? And so all we're left with in the numerator is just the x minus 4, right? And then the denominator is really just 1. So this is really just x minus 4. And that's our final answer here. So I hope that helps. Okay, so let's do another one. And this should be an easy one at this point, because most of you have done these before. We simply want to add 1 over 6 plus 3 over 10. 1 over 6 plus 3 over 10. So this is, we'll call this example 2, 1 over 6 plus 3 over 10. Okay, so add and simplify. and simplify. All right. Well, notice that in this problem, 6 and 10 are not the same number, right? So we don't have the same denominator. So we can't add 1 plus 3 here. That doesn't work. What do we have to do instead? So going back to this, we have to find the least common denominator. So 6 and 10, what's the LCD? What's the least common denominator out of 6 and 10? So this is step 1, LCD, least common denominator. Well, 6 is just 2 times 3, and 10 is just 2 times 5, right? So all the exponents are 1s. So the least common denominator, you just multiply each factor to the biggest exponent. The exponents are all 1s. So we have a 2, we have a 3, and we have a 5. So 2 times 3 times 5 is, oops, not 60. 2 times 3 is 6, 6 times 5 is 30. Sorry about that. So our LCD here is 30. Okay, so far? All right, so that's step 1. Step 2 is to rewrite each fraction so the denominators are the LCD. The denominator has to be 30 here. Okay, so let's go back to the original problem here. We have 1 over 6, leave some space, plus 3 over 10, right? And we need to multiply by whatever's missing here, right? So we want the denominator here to be 30, but we only have a 6. So let's see what's missing. 6 times what equals 30? Well, 30 divided by 6 is 5. So 30 is really just 6 times 5. Sorry, times 5. So that tells me I have to multiply the denominator by 5. But I also have to multiply the numerator by the same thing, right? Because I'm only allowed to multiply by 1 here. 5 divided by 5 is 1, right? On to the second fraction. We have 3 over 10. But we want the denominator to be 30. So 10 times what is 30, right? 10 times 3 is 30. Or if you take 30 divided by 10, you get 3. So I have to multiply the denominator by 3. That means I have to multiply the numerator by 3. Again, coincidence that this is also a 3 here. Okay. All right. So what do I get? For the numerator, I get 1 times 5 is 5. 6 times 5 for the denominator is 30. Right? For the second fractions, I get 3 times 3 is 9. And then 10 times 3 is also 30. Right? So first, recognize that these two fractions here are not in lowest terms anymore. But that doesn't matter because now we have the same denominator, right? And what do you do once you have the same denominator? Right? You just add or subtract. In this case, we're adding the numerators. Right? So in this case, this is our step 3 here. Step 3, we write one big fraction divided by the denominator 30, and the numerator is just 5 plus 9. Which I hope you can do that in your head. 5 plus 9 is 14 over 30, right? Okay. Now, are we done? So step 4, simplify if necessary. Notice that 14 over 30 is not in lowest terms. So no, we have to go one step further here. We have to go one step further. So step 4, reduce this to its lowest terms. So 14, how do you factor 14? It's just 2 times 7. 30, well, remember where 30 came from. That's 2 times 3 times 5. So notice that 2 divided by 2 is 1. That's our common factor, so that cancels. And we're left with a 7 in the numerator and 3 times 5 in the denominator. 3 times 5 is 15. So our final answer should be 7 over 15. Okay. So, right. So again, this was an easy one, I hope, but this is the way you should be thinking about it. Okay, so if that was example 2, let's do another example. Example 3, 3x plus 1 over x minus 6 plus x plus 13 over 6 minus x. So So yeah, if that's not clear, let me write it again. This is 3x plus 1 over x minus 6 plus x plus 13 over 6 minus x. Okay, so what do we notice here, right? So find the LCD. Well, I'll do that way up here. So we have two denominators, right? We have x minus 6 and we have 6 minus x. They're not the same thing, obviously. However, we don't have to we shouldn't just multiply these, right? Because 6 minus x is really, it's just the opposite of x minus 6, right? Remember that whenever you're subtracting two things, say a minus b and b minus a, they're not the same thing, of course. They're just opposites, right? One is just -1 times the other. So rather than multiply these two denominators, it's probably going to be better if we just change the second fraction. So we still have 3x plus 1 over x minus 6. And then write this as x plus 13 divided by -1 times x minus 6. And since we have a negative in the denominator, we can actually bring that up front and just now subtract instead of add. Okay, so essentially, right, what was a -1 down here, and this was a plus, right? This was a plus. When you add a negative, you're just subtracting, right? Okay, so yeah, rather than do that, let's just think of subtracting these two fractions now. And since the denominators are the same, right, we can just subtract the numerators. This is 3x plus 1 minus x plus 13 all over x minus 6. So distribute the negative sign here. We're going to get 3x plus 1 minus x, and then minus 13, right? -1 times 13 is -13 divided by x minus 6. Okay, so far. So what can we simplify here? So we have 3x minus x, that's just 2x. And then we have a +1 minus 13, that's just -12. Okay, so 2x minus 12 over x minus 6. But can we simplify? So what can we do with the numerator here? We have 2x minus 12. Notice they both are even numbers, so they're all divisible by 2, so I can factor out a 2 here. This is 2 times x minus, well, 12 divided by 2 is 6. And look at that. We have the same x minus 6 in the denominator, so that tells me I can actually cancel the x minus 6, right? Because it is a factor here. You are just multiplying. So x minus 6 divided by x minus 6 is 1, leaving you with just 2 divided by this invisible 1 here. But 2 divided by 1 is just 2. So believe it or not, all of this stuff up here, when you add and simplify, you just get the number 2. And so that's the answer to this problem here. Okay, so I think this is our fourth example. And this one's going to be a little bit trickier. We have a minus 3 over a squared minus 5a plus a minus 9 over a squared minus 25. All right, so yeah, first thing I'll do is just copy it down so I can play around with it a little bit. A squared minus 5a, that's a 5, plus a minus 9 all over a squared minus 25. Oops, 25. Okay. All right, so step 1, find the LCD. So we have these two denominators here. Let's go up here. Step 1, what's the LCD? So we have a squared minus 5a, and the other denominator is a squared minus 25. So to find the LCD, we have to factor them first. So a squared minus 5a, the GCF is a, so just factor out the a. This is a times a minus 5. And the denominator is a squared minus 25. So that should remind you of a squared minus b squared. Right? Remember that? A squared minus b squared. It's the difference of squares. It factors as a minus b times a plus b. So here a is a, well, lowercase a is the capital A, and the capital B is really just the 5. So a minus b times a plus b is a minus 5 times a plus 5. Sorry, that's a 5, not an S. Same thing here. So what's our LCD? Well, we have to include every factor. So we have to include the a here. So that's one of the factors. We have to include the a minus 5. Right? So we already did that here. We don't need another a minus 5. But we also need an a plus 5. Okay? So no, yeah, remember we multiply each factor to the power 1. We don't have to duplicate the a minus 5, right? In other words, you don't want to do a minus 5 squared. Well, you could. It's still a common denominator. It's just not the least common denominator. So I would prefer not having the exponent of 2 there. The biggest power is just the 1 here, right? Okay, so that's step 1, finding the LCD. Right. Step 2 is, well, rewrite each fraction so the denominators are the LCD. So here's the first fraction, a minus 3, divided by a squared minus 5a, but remember we factored that as a times a minus 5. And then the second fraction is a minus 9 divided by a squared minus 25, sorry, that's a 2, and we factored that as a minus 5 times a plus 5. Okay. So all I did was factor the denominators. Otherwise, it's the same question here, right? Okay. Well, now we want both denominators to be the same. So we have to rewrite each fraction so that the denominator is this thing up here, right? The LCD. All right. So notice, what do we have in the first fraction? In the first fraction, the denominator contains an a and an a minus 5. The LCD has an a and an a minus 5. So we already have those. What we don't have is the a plus 5. So I'm going to multiply the denominator by a plus 5, and that means I multiply the numerator by the same thing, a plus 5. So now this is our LCD. Okay, so we're good with that. For the second fraction, we have a minus 5 times a plus 5, right? And so in the LCD, we have a minus 5 times a plus 5. What are we missing? We don't have the a here. So I have to multiply denominator by a and the numerator by the same a. Okay? So when I do all that, right, now the denominators are the same. Well, the a should be in front, of course, but that doesn't matter, right? It's just to keep the same order. So, yep, the denominator is now a times a minus 5 times a plus 5. That's an a. The numerator is going to be, well, this plus this, right? So now we're just adding the numerators. A minus 3 times a plus 5 plus, and then I bring this a in front as well, put it over here. So this is going to be a times a minus 9. All right, and now we get a pretty big mess here, right? So the one thing that we have to be very careful of, a lot of students look at this and say, well, look, we have an a plus 5 here, we have an a plus 5 here, we should cancel those. You cannot do that. I just want to really emphasize that this is a very big mistake. People do that all the time, and it's just you're gonna get it wrong, right? So don't make that mistake. You cannot cancel anything at this point. You could have canceled them here in this step, right? We could have canceled these, but then we're back to square one. We're back to the very start here, right? So yes, these two fractions here, this fraction and this fraction, are not in lowest terms anymore because they have common factors that we could cancel. Okay, they're not in lowest terms, right? However, that's okay. The point is they had the same denominator, right? We got the same denominator so that we can add the numerators. Remember, you can only add or subtract the numerators when the denominators are already equal. Originally, they weren't equal. By doing this, by finding the LCD and multiplying by the a and the a plus 5 here, we ended up with the same denominator now, right? So that allows us to add the numerators in step 3, right? So, of course, this was step 3. Oops. Step 3 here. Okay. All right. Now what? Now comes the simplify part, and this is going to be a little bit of algebra here. Right, so we can't cancel anything here. However, what we can do is expand this out. We can multiply it out, right? So only do that to the numerator. Let's leave the denominator alone. We have to FOIL the numerator, right? A times a is a squared. It's going to be one very big fraction. A squared times 5a minus 3a. 5a minus 3a is 2a. And then negative 3 times positive 5 is negative 15. Okay, so far. Now we have a plus, so that's going to be a plus. A times a is, well, a squared. And then a times negative 9 is negative 9 times a. Right? And all divided by the same denominator. Now, you might be tempted to multiply this out too. You should resist that temptation because that would be not helpful. Okay, leave the denominator alone. Now, for the numerator, what do we have? We have a squared plus a squared. That's just 2a squared. Now we also have this 2a minus 9a. So 2 minus 9, 2 minus 9 is negative 7, right? So negative 7a, and then minus 15. All over, again, let's just copy down the denominator. We're not trying to multiply that out. Right, a times a minus 5 times a plus 5. Okay, so all that's just step 3. And, well, I guess you can consider this part of step 4 as well. We're simplifying now, right? But what does simplify also mean? Simplify also means factor and cancel. So the denominator is already factored, right? We never bothered multiplying it out, so we don't have to factor anything in the denominator. However, the numerator is not factored. So let's see if we can factor the numerator. I'm just going to copy the denominator down first here. Right, so how do you factor 2a squared minus 7a minus 15? That's not easy. So let's do that way up here. 2a squared minus 7a minus 15. Well, GCF is 1, and a is 2, b is negative 7, c is negative 15. So it looks like we're going to have to use the AC method here, right? A times c is 2 times negative 15, or negative 30. So can we find two numbers that multiply to negative 30 and add to negative 7? So if it's not obvious, let's go through the list. Negative 30. So it's not going to be 1 and negative 30, because when you add those, you get negative 29, not negative 7. So how about 2 times negative 15? Well, 2 minus 15 is negative 13, not negative 7, so that doesn't work. What about 3 times negative 10? Well, 3 minus 10 is negative 7. Oh, there's our match, right? That's what we wanted. So that means we can take the 2a squared minus 7a minus 15 and split up the negative 7a as 3a minus 10a. That's an a, right? Leave the negative 15, and then leave the 2a squared in front. So now we can factor by grouping. Factor out of the first two terms, all we can factor out is an a here, leaving us with 2a plus 3. And then from these two terms, we can factor out a negative, because this is negative, 10 and 15 both have a common 5, so we can factor out a 5. And when we divide, we're left with 2a, and negative 15 divided by negative 5 is positive 3. So we can now factor out the 2a plus 3, and that multiplies a minus 5, right? So that's the numerator in its factored form. Hang on. So yep, this is going to be in parentheses 2a plus 3 times a minus 5. A minus 5. Okay, so that's the factoring part. Remember, simplify also means factor and cancel. We did the factoring. That took a while. And cancel. Can we cancel anything? So I see an a minus 5 in the denominator. I see an a minus 5 in the numerator. And these are factors. These are just multiplied, right? So because you're just multiplying, that means we can now cancel a minus 5. And so that brings us to what's left over on top, 2a plus 3. And in the denominator, we have an a times a plus 5. And there is our final answer, 2a plus 3 over a plus 5. And so that's the original question. To simplify, we simplified all this mess here, and we end up with 2a plus 3 over a times a plus 5. I'm just copying down the answer, and that's what we end up with. So yeah, this was a little bit harder, but it is, I think, a reasonable question. It just might take you a little bit longer to go through all 4 of these steps here. Especially step 4, the simplifying part, involved all this factoring here. This is all just factoring by the AC method. And then the canceling, that's the easy part, right? But you have to make sure you factor correctly. If you factor wrong, if you factor incorrectly, then you might not get the right answer. So just be aware of that. So I hope this helps. I don't suspect you're going to see too many problems much more difficult than this. This, I think, is kind of a medium one, maybe a little bit on the more difficult side, but this should be about as bad as it gets. So I hope that helps.